Hi Year 9, welcome to your intro videos. So this week we're going to just go over something done lots and lots before. We did this lots at the beginning of the year, which is solving linear equations. Now last week when we did solving more complex equations, I noticed that you'd forgotten how to solve linear equations, so that's why we're doing it. And I cannot stress enough just quite how important the ability to solve a linear equation is. Okay, remember I said at the beginning of this school year, if you only learn one thing this year, if you only remember one thing, then it will be linear equations, because it's going to come up again and again and again and again. Okay, so we've got an equation here. We've got to find out what is the value of x that makes this equation true. So we've got 4x minus 5. I always like to write down the equation first. And then what we're going to do, we use this balancing method. Okay? The first thing we're going to do here is I'm going to add 5 to both sides of the equation. Add 5. Okay? And now what do I end up with? I'm going to end up with 4x equals 30. Okay? And then what we can see, because the whole idea is to get x all on its own on the left-hand side, we're going to divide both sides of the equation by 4. Well, that means I'm left with x on the left-hand side and 30 over 4 on the right-hand side. Now, you may notice that 30 doesn't actually divide by 4. That doesn't matter. You can leave your answer as a fraction, but always turn your fraction into its simplest form. So x is equal to 15 over 2. Okay, and if you really want, you don't have to. You really don't have to do this. I actually kind of recommend you don't do this. If you really want to, you can turn that into a decimal to be 7.5, or a mixed number, 7.5. Okay, but I'm totally happy with this, because actually the ability to use fractions properly it makes life much easier in the end. So sometimes your value of x is a negative number, sometimes it's a fraction. It's not always a nice number. Now, what you can always do is you can always check your answer by subbing your answer back into the original question. So here is my check. Just check I've done it right. I'm going to do 4 times 15 over 2, okay, minus 5. And let's see what that is equal to. Well, that means 4 times 15 over 2, and you should remember your rules of fractions, so we're also going to be remembering how to multiply fractions. So there's another very, very, very important topic, okay, so bringing them all together into one topic. You know, fractions, linear equations, is the two things that hold students back the most. Okay, so 4 over 1 times 15 over 2 becomes 60 over 2 minus 5. Well, 60 divided by 2 is 30. 30 minus 5 is equal to 25. So everything is turning out to be true. When I put the value of x that I found out in, I got out 25. So I know I'm right, okay, because I found my answer in by a correct method, and I checked it, and it came out, and it confirmed that what I thought was correct. Okay, so always do a little check, and then you'll know that you're getting things right, and you can have confidence. Right, okay, let's have a look at another question. So what about this one? X over 4 plus 5 equals negative 8. So again, what I'm going to do is I'm going to subtract 5 from both sides of the equation, which is going to give me x over 4 on the left-hand side. And then I'm going to do minus 8 minus 5. Use a number line if you need to. We're at minus 8, and we're moving to the left 5. So you've got minus 13. And now what I'm doing, because on the left-hand side I'm dividing by 4, what I'm going to do is multiply both sides of the equation by 4, so that I get x on the left-hand side, and on the right-hand side, minus 13 times 4 is negative 52. Okay, so x is equal to negative 52. Let's do a little check. So put minus 52 over 4 plus 5. Well, how many 4s into negative 52? That would be negative 13. Negative 13 plus 5 is negative 8. My check confirms that my answer is right. Okay? Always do that check. Right, what about here? Let's see, we've got 2x minus 3 over 3 equals negative 2. Now, in the past, what I've always dealt with is the plus or the minus first. So, you know, it might be easy to think that I'm going to add 3 to both sides of this equation, but I'm not. Basically doing bid mass in reverse. Okay, so what I need to actually do is multiply both sides of this equation by 3 first. And I'll end up with 2x minus 3 equals minus 6. Now it becomes easy. All I want to do now is add 3 to both sides of the equation. So 2x equals negative 3. Now I will simply divide both sides of the equation by 2. And x is equal to negative 3 over 2. And again, I'm really happy for you to leave the answer as a fraction. You guys are so frightened of fractions. I really don't know why. They're very, very simple, okay? As soon as you get an answer that's a fraction, you think, I don't know, it must be wrong, something's gone crazy. No, the answer's a fraction, it's fine. And fractions are easy to deal with. So leave your answer as a fraction. Okay, but we can still do my little check because you understand fractions really well. It should be an easy check. Okay. We're going to substitute minus 3 over 2 in. So 2 times minus 3 over 2 minus 3 over 3 on the left-hand side. Now, what's 2 lots of minus 3 over 2? Well, that is going to be minus 3. Essentially, the 2's will cancel away. So you're going to end up with minus 3 over 3, which is minus 6 over 3, which is negative 2. So my check confirms that I got the answer right. Okay? Now, I'm going to stop doing checks now, but you won't. You'll check for every single question, okay, so that you're confident that you're getting it right. It's really, really good for you to know you got it right. And it's also good, if your answer is a fraction, then it's really good for you to just practice your fraction work, okay? Right, what about this one? Got a couple of options here. There's 2 things you can do as your first move. Let's get the right colour. So we've got 3 times 2x minus 1 equals negative 21. Now, what I could do is the first move is to divide both sides by 3. So I'll just carry on doing it that way. And so then end up with 2x minus 1 equals minus 7. Now, add 1 to both sides. I will get 2x equals minus 6. Then I will divide both sides by 2. And I will get x equals negative 3. That is one way that you can do that. But there's actually a second way. What you could do first, instead of dividing by 3, what you could do is expand the brackets. So you get 6x minus 3 equals negative 21. So then add 3 to both sides. 6x equals negative 18. Divide both sides by 6. Then x equals negative 3. It doesn't matter which way you do that, you will get the same answer. And I'm not going to do it now, I've shown you what to do, but you can substitute x equals minus 3 into the original question and check that the left-hand side is equal to minus 21. Okay, if it does, you know you did it right. Okay, what about this one? This one we're definitely going to expand the bracket first and then simplify the left-hand side. Because you can't divide by 3 because 3 is not a factor of the whole of the left-hand side. So we're going to do this. We're going to go 2d plus 3d minus 3 equals 7. Now let's collect together like terms. So I get 5d minus 3 equals 7. And now I've got a nice equation I can solve. Add 3 to both sides. 5d equals 10. Divide both sides by 5. Then d equals 2. Okay? And again, you can check. Substitute 2 into the original question and see. Do you know what? Let's do it this time. Let's do a little check. Let's substitute in. So we're going to get 2 times 2 plus 3 times 2 minus 1 equals 2 times 2 is 4. 2 minus 1, we're just using bid maths correctly here. 2 minus 1 is 1 times 3 plus 3 equals 7. So my check confirms that I'm right. Okay. Right, what about this one where we've got x's on both sides of the equation now? Let me just write down the question. I always like to write down the question. Helps me get started. Now, we can certainly subtract 2 from both sides of this equation. So we're going to end up with 3x equals x plus 12. And then people panic again. Why? Because you forget that x is just a number. So if you can subtract 2, then you can also subtract x. So why don't we subtract x from both sides of the equation? And that will have the effect of killing the x from the right-hand side. 2x equals 12. And remember, 3x minus x is not 3. If I have 3 monkeys and I take away a monkey, I've got 2 monkeys. Okay? So now what we'll do is we'll divide by 2 on both sides. So x equals 6. Okay? I will do a little check for this one because nothing is different. Here is my check. Right, sub 6 into the equation. We're going to, 6 for x. So 3 times 6 plus 2 equals 6 plus 14. 18 plus 2 equals 20. 20 equals 20. Everything is working out to be correct. Okay, I must have done it right. Okay, here we got one where we've got brackets. So nothing different. We're going to expand the brackets first. Let's just write the question first. Okay, expand the brackets first. 3x plus 6 equals x minus 1. Well, now it's exactly like the previous equation. So we will subtract 6 from both sides. And we'll get 3x equals x minus 7. We will now subtract x from both sides because that will remove any x's from the right hand side. So we'll end up with 2x equals negative 7. And x, we're dividing now by 2 on both sides. So therefore x is equal to minus 7 over 2. Again, very comfortable leaving it as a fraction, because if I need to use that value for any other purposes, I know how to work with fractions. Fractions are easy. Okay? Okay, moving on. Right, x over 2 equals 3 plus x over 5. So we're now talking about equations that have fractions, okay? X over 2 equals 3 plus x over 5. Now, there are 2 ways that we can do this. I'll tell you both, okay? Now, one way of doing this is to try and get a common denominator, okay? So if we've got denominators of 2 and 5, a common denominator could be 10. So let's just rewrite both of these as equivalent fractions with a denominator of 10. Well, what that means, I've times, on the left-hand side, I've times by 5, and on the right-hand side, I've times by 2, top and bottom. So it means I'm going to get 5x on the top, and if I times 3 plus x by 2, for the love of God, use a bracket, please. Use a bracket, so that becomes 2 times 3 plus x. Okay? Now what we'll do is we will expand the bracket, so I'm going to keep 5x over 10 is equal to 6 plus 2x. Okay? Now, because the denominator is the same, we can now ignore it. Because effectively, all I have to do is say that whatever is here must be the same as whatever is here. Because the denominator is the same now. Okay, so I don't actually need it anymore. So we can say 5x is equal to 6 plus 2x. What I'm definitely going to do here is I'm going to subtract 2x from both sides. I will get 3x equals 6, and then I will divide both sides by 3, and I get x is equal to 2. Okay, let's do a little check for this one, because it's a nice number. So 2 over 2 equals 3 plus 2 over 5. 2 over 2 is equal to 5 over 5. Therefore, 1 is equal to 1, and my check is complete, and I know that I got the right answer. Okay? Now, that was one way of doing it. Just to show you a slightly different way of doing it. It's effectively the same thing, but... Okay, again, let's write the question. X over 2 equals 3 plus x over 5. Now, what I'm going to do is I'm going to multiply both sides of the equation by 2. And what I get if I get that? Well, the 2's will cancel, so I'll get x equals 2 lots of 3 plus x over 5. Now, I will multiply both sides of the equation by 5 to get rid of the denominator on the right-hand side. So I will end up with 5x, and the 5's will cancel on the right-hand side, 2 times 3 plus x. Now we're in the same place as we were before. 5x equals 6 plus 2x. Subtract 2x from both sides. It's just a number, so there's no reason why you can't do that. 3x equals 6, and divide by 3, x equals 2. We get the same answer. Okay? Right, what about this one? 1 over 2x equals minus 3. Well, again, 2x is just a number. So if I can add an x or subtract a 4x minus 7x, I can also multiply by 2x. So what I'm going to do to this is I'm going to multiply both sides of the equation by 2x. Which means on the left-hand side, 2x's will cancel. I will be left with 1. Right-hand side, I will be left with negative 6x. So all I'm going to do now is divide both sides of the equation by negative 6. And so on the right-hand side, I get x. I'm switching it around. On the left-hand side, I get negative 1 over 6. Again, very happy to just leave that as a fraction. Why would I bother having to change it? Fractions are easy to work with. Okay? Right, same with this one. 3x plus 1 over x minus 1 equals minus 2. I'm quite happy to multiply both sides of the equation by x minus 1. But of course, I'll use a bracket. The result of that is that the left-hand side, x minus 1, will cancel, and I'll be left with 3x plus 1. And on the right-hand side, I will remember to use a bracket, because I'm multiplying x minus 1, all of it, by minus 2. And now it should be easy. It's just going to be a case of expanding the bracket. Okay, be careful with negatives. Minus 2 times minus 1 is positive 2. So I am going to subtract 1 from both sides. 3x equals minus 2x plus 1. Now I'm going to add 2x to both sides. Why not? It's just a number. Okay, and so I'm going to get 5x equals 1. Now I will divide both sides by 5. And x equals 1 over 5. Okay? And again, because I'm really, really good at fractions, I can probably put a fifth back into the original equation and check that that answer is right. Does the left-hand side equal minus 2 when x is a fifth? Okay? I won't do it now. I'll leave that to you. Right, last one. Okay? Again, because you're good at fractions, this shouldn't be too difficult. The first thing we need is a common denominator. So if I want to get a common denominator, I'm going to multiply. I want the common denominator to be 12. So I'm going to multiply this one by 4, top and bottom. I'm going to multiply this one by 2, top and bottom. And this one here is already 12, so don't need to touch it. Okay, and I will use brackets. 4 lots of x plus 1 over 12 plus 2 lots of x minus 2 over 12 equals x plus 4 over 12. Okay, now on the left-hand side, because they've got the common denominator, it's easy to add them. I'm going to get 4 lots of x plus 1 plus 2 lots of x minus 2 all over 12 because I have a common denominator. Now I'm going to expand and simplify the numerator on the left-hand side. So I get 4x plus 4 plus 2x minus 4 all over 12 equals x plus 4 over 12. I'm just going to move up to the right-hand side. Again, I've expanded. Now I need to simplify. Well, 4 minus 4 is nothing. 4x plus 2x is 6x. So I'm going to get 6x over 12 equals x plus 4 over 12. Now, because the denominators are the same, I don't need them. It means that 6x must be equal to x plus 4. Whatever's here must be the same as whatever is here. Denominator's already the same, so I don't need to worry about it anymore. And then I will subtract x from both sides. So I'm going to get 5x equals 4. Divide both sides by 5, and x is equal to 4 over 5. And I'm so delighted to just leave that as a fraction. Fractions are easier to deal with than decimals, actually. I'd much rather work with a fraction than a decimal. It's just easier. Okay, so there we go. There's a whole range of linear equations for you to be able to solve. So all of this week is just going to be about practicing these concepts, okay? Now, if I just sort of link that back to last week's work, so you know how to solve linear equations using these methods that I've given you. But now you also know how to solve more complex equations. Let's say you had something like this, x cubed plus 2x equals 1 over x plus 1. Well, you should now know that you will not try to use the same methods that I've taught you for linear equations that I've just gone through in this video, but that you will make two graphs, y equals x cubed plus 2x, and you will make another graph, y equals 1 over x plus 1. And you will graph them, and you will look for points of intersection. Look for points of intersection. So I'm just going to do it. I'm going to get Desmos up. Where's Desmos? On here, Desmos. Just need to remind myself what it was. X cubed plus 2x. Y, we're going to say y equals x cubed plus 2x on the left hand side, and you're going to say y equals 1 over x minus 1, I think I said. Let's just check. Oh, I said x plus 1. Okay. So let's change that to x plus 1. And where are the solutions to this equation? The solutions to the equation is where they intersect. Okay? So one solution is the x value there, which is 0.349. And then the other one is the x value at the other point of intersection, minus 1.231. So actually we had two solutions. So you can use this method whenever you're coming up against a really challenging equation. So I think I've lost it there. But, you know, we had an equation like this, x cubed plus 2x equals 1 over x plus 1. And by just using a graph, you were able to find the solutions, okay? So you can do all sorts of linear equations, but actually now you can do any equation that possibly exists using that method. So there's no excuse. You get an equation, you can always solve it, okay? All right, done there. Please let me know if you need any help.